All right, we're going to take a look at building the end plate in 3D. We're going to use AutoCAD for this. We're going to develop the solid in the model space and then use the B-size layout in paper space for presentation using the sole view and the sole draw. Let's take a look. Now keep in mind that what you want to do here is for each of these parts, we're going to start with the template. Okay, so make sure you have that handy, and then also make sure you create a project folder. Now once you open up a new drawing based on the template, switch over to the model space. Okay, make sure that you're going to be using the 3D modeling workspace. Now since we're going to be using layouts for our presentation, we really don't have a need for the grid here, but just keep in mind the F key shortcuts to turn on and off most of your drafting settings, as this is going to help your drafting. Okay, either to locate or visually see the UCSs as they change, or even to control the O-snap to turn that on and off. Okay. The other thing is too that when you're ready to annotate, just pay attention to your annotation scale here. And as you model, what you want to keep in mind is you're going to be using the 3D layer that'll contain all the solid geometry. And as you develop the sole views, you'll have to come back to your layer properties so that you can change the colors or check the line types for all of the newly created layers that occur with the use of sole draw. All right, so let's start out. If we take another quick look at the drawing here, we can see that we have our front view and our top view. Here's an isometric view. Now as you work with the model, you might want to split up your viewport, so we'll take a look at that. But I would recommend that we start with the front view with the end plate here. So you could, if you wanted to split up your screen, use view, use viewports. You could split it into 2 or more viewports. Here, if I use the vertical option, you can see I have any of my ortho views in the left side, and on the right side I could easily just use my heads-up display here to switch to an isometric view. Now again, if I turn on the grid, you can easily see the orientation of the UCS, and notice up here that I can create and switch or toggle between UCSs here. In order to toggle UCSs without having to create them, you can also take a look at your view tab. Whenever you switch to a standard view, it also switches the UCS. So notice this, I'm in the southwest isometric view. If I quickly switch to the front and then switch back to the southwest isometric, you can see I still have the front UCS. Okay, all these UCSs, the standard ones anyway, are coincident with the origin. Okay, so what I can do here is I'll switch to the front view, and consequently the front UCS. This is still my origin, and I'll just focus here on the left viewport. What I'm going to start off with are some reference lines, and for that I'll just use my center line layer here just to start off with some construction lines, vertical at 0, 0, the origin, and a horizontal one also at the origin. Now what I want to do is just develop the geometry. So if I switch over to a 3D layer here, and I can do this a number of ways. I can use offsets, or just use my rectangle or line tool. You can decide for yourself. But if I offset either side 2 inches, you can create all the outline intersections. Okay, and then just using regular 3D or 2D geometry on the 3D layer, we can just trace out the profile. Okay, and as you model here, go ahead and think about removing any of these extra reference lines. So all we have is the profile. Let's go ahead and continue with the details here. So I'll do a center hole here of diameter 1, set that, and then I've got these other holes about a center hole that is a radius of 0.813. So at this point, I'll just draw a circle with radius. Yeah, it's already set to radius, and this is 0.813. Okay, I'm going to be using this just for reference. I'll get rid of it in just a moment. Also, each of those holes are set at 45 degrees. So another way that I could set this up is if I start from the center here, you can see I'm using my polar tracking there. I could find the intersection with that center hole, and then I could draw my hole there of diameter 0.188. So D for diameter, 0.188. Then I could get rid of these temporary lines. Now to complete the pattern here, you can do this a number of ways. You can go ahead and lay out some more reference geometry, or you could simply use a polar array pattern. So for that, if we look at modify, we're going to use polar array. We'll select the object that we want to array, hit enter, and we'll start here as the base, and when you look towards the top of the ribbon, you'll have your properties. Okay, we know we want a total of 4, and you can see the angle between them is 90 degrees for a full 360 degree fill. Once you review and you accept the changes, just go ahead and hit enter, and that part is complete. Now we just have corner holes here on either side. We have about a ½ inch away from the edges there. So I'm just going to bring back a couple construction lines, temporary ones anyway. Offset towards the inside by ½ inch. And that way I could find my center mark there. Again, I'll place a circle with the center there, and this is a diameter of 0.250. Now again, we could create a rectangular pattern here, or we could simply make use of those reference lines to mirror. So if I use the mirror command here, select my object, hit enter, and then use 2 points along the mirror line there to reflect that hole, and then I could mirror again both holes and use 2 points along the horizontal line there to mirror those 2 holes. Now, for the most part, this is all the geometry I'm going to use. And what I have right now is basically a rectangle and a set of holes. Okay? The next step here is to actually use regions to do the subtraction so I can produce the holes, and then to extrude the object by ½ inch. So first of all, if we take a look at draw, right, you have the different options for making boundaries, right? Or we can just go ahead and use the region tool. So if we use the region tool, I'm going to select all of my entities there. Okay, the rectangle and all the holes, and then hit enter. Now, there may not have been much done except for the fact that you see in your command line 6 regions created. In the other viewport here, the isometric, if I change from 2D wireframe to conceptual, you can see that all those holes are solid surfaces, right? Planes, okay? So what we'll want to do here is we'll want to go ahead and use subtraction. Use subtraction to produce the holes. So just before we continue with the subtraction of the regions, pay attention here to these holes. Now you'll notice that in our isometric view here, we don't see the outlines. And the reason for that is because these are still part of a group in that array. Now what we'll need to do here is let's use the explode command. Now that we have the array that we want, we don't need to make any more edits. So we can use the explode command, select any one of those instances in that array group, and just explode. Now we can come back here to draw and convert those 4 holes to regions. So we can proceed. There we go. So we got all the regions now. And if I switch over again to the isometric view, this way it's easier to see what I'm selecting. Let's turn off that grid and let's start with subtract. I'm going to subtract from the larger rectangular area and then hit enter and then select all the interior profiles, all these holes here. And then hit enter and we should have holes. And then now when I extrude, again working in that isometric view, now I'll extrude a total depth of 0.5. And you'll see here I have all my holes through. Okay. And as I zoom in, notice the choppiness of those curves. What I'm going to do here is change the facet resolution, which is face tress. The default value is 0.5. I'm going to bump it all the way up to 10. Okay, and then zoom extents. Now this is our model here. Okay, and for all intents and purposes, this center line here, I'm just going to get rid of it because now we're ready to go ahead and start doing the drawing presentation. Let's switch over to the paper space to do that.